Want to present x is greater than or equal to -1 but less than or equal to 3. The interval notation is exactly what I see, x in the interval -1 comma 3. So this is the interval notation. The set builder notation, it's fine. I just personally don't care for it. Here's why. Because the set builder notation would mean x is in, to be exact, the following set. In the set, and you have to put braces. You have to say x, because x is the variable. You have to write x. You have to write a vertical bar, which stands for having the property. Or such that. So this is the set of x, values x, having the following property. What property? This one. So I don't see any difference, per se, between that and writing this. It's the same thing. The interval notation, however, is more useful. So be careful what you put in, because my math lab may consider it wrong. Good, that was a perfect question. Thank you for clarifying that and bringing that to my attention. Good, next question. Anything else that you worked on? Anything else that you would like to see? Anything before we continue?
Yes, I actually have another question.
Yes,
I was
please.
hoping we could go over intersections and unions.
Yes.
Last class you said the unions.
Right, very good, very good.
This equation, all of the values of this, and also all the values of this.
Perfect.
But
So let's talk about union. And there are two different situations. Union of sets and intervals. So we can create a union of two sets, or we can determine the union of two sets if you want, or we can determine the union of two intervals. So let's start with the union of sets. So let's suppose I have a set that is set A. I'm using a braces when I list the elements, or when I use the set builder notation, which you will probably not ever see me do that. So let's say I have A, which is -3, 0, 4, and 9. I'm just making this one up. And another set, which is B. And let's say B has 4, 7, 11. And let's suppose I want to create the union. And let's suppose I want to create, since I'm here, I'm going to say union and intersection. I will put both of them in the same table. Okay. So first of all, this is the union. And this is the intersection. So the notation is U for union and upside down U for the intersection. The key word here is or. Conjunction or. And the key word here is and. Yes, please.
Could you show an example of like an intersection on a number line?
Yes, I will do that too. It will not work for sets. It will work for intervals. So when we get to intervals, I'll show that. Yes. Okay. So first of all, how do I determine the union? Here's what the union says. First of all, the union is a more relaxed type of relationship. Here's a silly example. I will go to the beach if I have a chair, or if it doesn't rain. I know they're not really connected. So I'll go, not a good example. Let me give you a better example. I'll go to the beach if Anya and Brian come with me. That's the end. If one of them says no, I can't go. What about the or? I'll say I'll go to the beach if Ryan or Anya comes with me. Just more relaxed. At least one of them can say. If both of them say yes, that's fine. I'll go to the beach. If at least one of them said yes, I will still go to the beach. The and relationship requires both of them to come with me. So it's a much stronger relationship. So now looking at these two sets, let's create a union. The union has everything together, put together, written only once. So let's say you have in your pocket -3, 0, 4, and 9, and I have in my pocket 4, 7, and 11. And we're not asking ourselves what we have in common, but if we want to put everything on the table, what do we have together? And the answer is absolutely everything. But 4 cannot be considered twice, because it's only one number. So then the union will be -3, 0, 4, 7, 9, 11. So that's the union. Everything put together, written only once. So let's write it. So A union B, again a brace, you have to use braces. And I list everything in the correct order, listing them only once. So this will be the union of these two sets. Now I'm sure you got the idea, and I would like you to tell me what will be the intersection of these two sets. In other words, the element has to be in both sets. Both have to agree to come with me. If one of them says no, I can't go. So then what will you say the intersection of these two sets is? Exactly. And I still have to use braces because I'm listing, and it's only one element in this case. So this is a difference between union and intersection for sets. Now, what if I have, let's say, set C, which is 0 and 4, and set D, which is 7 and 10. If I ask find the union, oops, C union D, and if I ask find the intersection, what will you say about the union?
0, 4, 7, 10.
The union is 0, 4, 7, 10. And the intersection? Right. So here's how we write. This is one option. And this is the other option. This is the Greek letter phi. Or you can just write the empty set. There's nothing in there. Not 0. You cannot list any element. It's completely empty. So you either use this or this or this. It's up to you. Okay, so let's come back to intervals now. Is it clear the difference between and or? Okay, so let's go back to intervals. So let's say I have, and I will show also with the real line or number line. So let's say I have the interval -1 infinity. And let's say I have the interval -infinity 7 with a parenthesis. And I'm asked to find a union. So -1 infinity union -infinity 7. And I'm asked to find the intersection of these two. Okay, so let's take a look at the real line. I'm going to graph both on the real line. 0 in the middle, -infinity to infinity. Do not bother with units because that's not the purpose here. Just go ahead and graph. So I'm going to graph -1 to infinity here. Notice that I put a bracket. So that's the purple interval. And I am going to graph the interval -infinity to 7. And it's a parenthesis. And it will be the yellow graph. Or yellow-greenish, yeah, graph. Something like that. Okay, so now I can answer both questions. Which questions? What is the union of these two? The same question. You have the yellow set, forgive me, the yellow interval, and I have the blue or purple interval. It's purple but it looks like blue here. So you have the yellow, and I have the interval, and I have the blue interval. Remember what we do? We put everything on the table and see what we can share together, not what we have in common. So we empty our pockets, and this is what we have, and this is what we work with all together. That's the union. Now the intersection says an element is an intersection if you have it and I have it. If one of us does not have it, it cannot be in the intersection. Okay, so what will you say about the union?
Negative infinity to infinity.
Very good. We have everything. You have the yellow and I have the blue. It turns out that we have everything and we cannot write elements twice. We share everything. So now the question is, what is the intersection of these two? It's only where I see both colors. Yes, it has to be from -1 to 7 with a parenthesis. Because 7 is in one interval, but it's not in the other. So it cannot be included in the intersection. If I had a bracket here, it would have included 7, because it would have been in the yellow set as well as in the blue set. Any questions? Does it make sense? Okay. Is there anything else that we need to go back to? Anything else that we? Yes.
So about inequalities.
Yes.
So you can multiply or divide and you don't have to change the sign. It's just when you do a negative.
Yes.
Okay.
Yes. So for example, if I have 2, keep 2 less than or equal to 10, if I divide everything by 2, I get 1, and this is 5, and this is still true. But if for the same inequality I multiply both sides by -1, I get -2 and -10, and this cannot be correct anymore. I have this. This time -2 is greater than or equal to -10. Because -2 is to the right-hand side of -10. So everything that is to the right-hand side has to be bigger than what I have on the left-hand side. Any questions? Any questions on that? Any questions? Any questions? Have you worked on anything else? Have you found anything else that we should look at? If not, I would like to move on to section 2.2 that presents more information about functions. Are we ready with that? Okay. So 2.2, the title is More on Functions and Their Graphs. Okay. One thing that I would like us to look at is functions can increase, decrease, or be constant. So let's suppose we look at the following graph. I'm creating a graph right now. Here's my graph. These are all dry. I thought I could save any, but maybe not. Okay, I just created a graph. I'm going to put some x values in here. I'm going to say that this is 3 and this is 5. And let's say this is 12. I claim that this is a function. Would you agree? This graph represents the graph of a function. Acceptable? How will I know? What will I do? I would use the vertical line test. Any vertical line will cross the graph in only one point, which means for any x value, I would be reading only one y value. Perfect. So this is a function indeed. Now, if you follow my marker, you will see that this function increases till it gets to this point. Then I'm sure you agree that it will decrease till it gets to this point.
and then it will be constant between these 2 points, and it will decrease. Acceptable? Okay. We are not interested when we talk about trends, we're not interested in identifying from which value till which value it increased, or vice versa, decreased. We're interested in the pattern, and here's the pattern. For any x value between negative infinity and 3, the function increases. For any x value, I don't care from where to what. From 3 to 5, the function is decreasing. For x between 3 and 5, the function is decreasing. For x between 5 and 12, the function is constant. And for x between 12 and infinity, what does the function do? That's it. That's all we have to write. Okay? So let's do it. So here's the way we write it. F increasing on negative infinity to 3. Some books present a closed bracket, which means including 3. I don't recommend it. I can show you in calculus we don't consider that at 3 at any particular point the function is a constant value. It's a value, right? It's not increasing or decreasing. So I recommend use parentheses. Okay. So now the function is decreasing on the interval 3, 5 union. Can anyone give us the other interval so we don't have to write it twice?
12.
Exactly, 12, infinity. And the last thing I have to write, the function is constant on the interval
5, 12.
very good. Very good. Okay, next topic. Is this clear?
Yeah, that's not in any way considered out of order, right?
No.
I mean, I see that you put the union. That makes sense.
All right. So I only have to write 3 things. Function increasing, on. Constant, never, maybe. Decreasing, on. So it doesn't matter. It has to be in ascending order from left to right. I'm not going to say that it's decreasing on 12, infinity, union 3, 5. So from left to right, yes.
So if there wasn't one of those, would you have to list the fact that there's
Not necessarily, unless the problem is asking you show or find whether it's increasing, decreasing, or constant. If it does say that, then you will have to say increasing on, decreasing never, constant on.
Okay.
That's it. Why do we do this? It's because this is another way of analyzing a graph. It's looking at the trend. Okay, so the trend here is up, down, constant, down. So we have an idea by simply reading from the graph. So these are properties of graphs. They can, or functions, they can increase, decrease, or being constant. Some of them have jumps, so that's possible too. But for a trend, these are the only 3 things that we look at. Okay. So now let's talk about 2 different things that a function can, 2 different properties that a function can have. So odd or even. This is called symmetry. Symmetry. So a graph of a function, or the graph of the function itself, can be symmetric in only 2 ways. So function can be, or its graph can be symmetric in 2 ways. One of them is odd, called odd. It doesn't mean 1, 3, 5. It's the name of the property. The function is odd. It's symmetric, and I'll explain what odd means. And even does not mean 2, 4, 10. It means that the graph is symmetric with respect to something that I will tell you in a moment, and that's why we call it even. Okay, so let's start with an odd function. I'm going to graph an odd function. Here it is. We will discuss this function later on in chapter 3.
but I need to illustrate with a function, and here is the function. And I'm telling you this function is y equals x to the third. It's a polynomial function, cubic function it's called. That's less important right now. So I am going to draw a line segment that goes through the origin and connects a point on the graph in the first quadrant to another point on the graph on the same graph in the third quadrant. Okay, I can do that anywhere I want, right? I can do it here. I can do it here. I can do it here. Anywhere. All these lines will connect, if I draw them through the origin, they will connect a point on the graph of the function from the first and the graph of the function of the third. Do you all see that, right? So it can be this, it can be this, but I will always be able to connect 2 points. Okay, so let's illustrate with one, just one segment, so we don't have too many in there. Okay. We kind of see some pattern here. And I'm going to say that this is x. Let's suppose we don't know what type of function this is. I don't really care. So let's say it's f of x. Can you please tell me what will this value be right here? And this is one thing that we just reviewed from last time. So if this is a function f of x, and this is x, what could this be for sure? Of course, it has to be f of x. Now, by construction and by graph, I think you will be able to give me the coordinates of this point. Take a moment and tell me what is this? Awesome. Stay with me. Do not look at the other side. And tell me what this is. Very good. Do we all agree with that? Perfect. So now I would like you to come up with a conclusion for me. Is there any relationship between this value? If this is, let's say, 10, how much will this be? Right. The negative, the opposite. The opposite. So obviously we will say that this function is symmetric, with respect to WRT, because I'm lazy, with respect to, and you'll tell me in a moment whether is it symmetric with respect to. And then I would like you to give me the relationship between f of negative x and f of x. You already told me. You already told me what is the relationship. You said that f of negative x must equal the that's it. So this is the relationship for any odd function. So if a function is odd, I'll show you how we prove it. With a graph, it's very easy. Without a graph, I'll show you in a moment. So a function to be odd, or if I need to convince you that a function is odd, I have to show you that f of negative x, which I will have to calculate, is the same with the opposite of the original function. If I show you that, then the function is odd, and its graph will be symmetric with respect to. So here's a graph on this side, right? And now here's the graph on this side. What is it symmetric with respect to? Exactly, the origin. Symmetric with respect to the origin. All odd functions are symmetric with respect to the origin. So we'll look at the other possibility, and then we'll have examples. So this is another very important property of a function. The previous one that we discussed was the trend, increasing, decreasing. We say monotony, basically, but we don't have to use that word. It's monotonic, we say. Okay, so odd functions have this property that f of negative x, in other words, I replace x by a negative x in the original function, and that answer, that expression will equal the opposite of the original function. We'll have examples. So here's another function. This is a very well-known function, and if you could tell me what it is, that would be great. Anyone remembers this function? Very good, awesome. So let's draw a horizontal line, dotted line. So this is a horizontal line anywhere you want. And I would like you to give me the coordinates of this point first, and then this point. So, of course, I'm going to say that this is x. What will this be right here? Very good. And what will this be? And don't look at the other side. Good, very good. And then don't look at the other side, please. No, that's what I said. Don't look at the other side. Very good. F of negative x. So what is the conclusion now? What is the relationship between f of negative x and f of x? Exactly. So this is the property of any even function. And I will say this function is symmetric with respect to the here it's much easier for me to show you. Here it is. Exactly. Indeed. So this function is symmetric with respect to the y-axis. Okay, I'm going to choose a function. We are on page 250. And I would like to look at let's start with 39 on page 250. And we are given the function f of x equals x squared plus x. We're not asked to graph the function, we're asked to algebraically show, so that's the requirement, show algebraically whether this function is symmetric. Okay? So, algebraically means I have to show this and I have to show this. A function cannot be both. There is one, to be exact. Y equals 0. This is the only function, which is this line. This is the only function that is symmetric with respect to the y-axis and with respect to the origin. But who cares about this function? I know that no one does, right? So we will say no function can be both. If I test that this is the case, and I say it's an odd function, then I don't have to test this. If I test this and I show that it's an even function, I don't have to test this. But if it's not odd, I have to check whether it's not even or if it is even. Okay? Whether. Okay. So, number 4. Page 4, I meant to say. Okay. So, as you see, in both cases, I have to determine f of negative x. Ready? So I'm going to copy the function here, f of x equals x squared plus x, and let's find f of negative x. How do I find f of negative x? This is based on what we did last time. What do I mean by that? Discussing how to evaluate a function. So I look at this function, and what does it tell me? It tells me to take the variable, square it, plus the variable. So now I want to plug in negative x. Can anyone dictate? Very good. Plus negative x. Awesome. This is it. Now I square negative x and I get, very good, x squared. And then I have negative x. So from here, I have 3 questions to ask myself or answer. Question number 1, question number 2, and question number 3. I ran out of room. I'm going to write the answers here. Does x squared minus x, does it equal the original function, x squared plus x? No. What do I conclude? That the function is f of x is not. Very good. What? When I test whether it's the same, I'm really testing the even property. If f of negative x equals the original function. So I will say it's not even, which means its graph will not be symmetric with respect to. Very good. Good. Now here's my next question. Does x squared minus x equal the opposite of the original function? Now I'm testing this property. If f of negative x, which I have determined, equals the opposite of the original function, does it? So this will be negative x squared and minus x. Are they the same? No. So what do I conclude? That f of x is not odd. And the last question is not symmetric. These are my 3 questions. Does f of negative x equals f of x? Does f of negative x equals negative f of x? Or none of the above? There is only one yes. If it's here, the other 2 are no. If yes is here, the other 2 are no. If yes is here, the other 2 are no. So what do we conclude? What is the answer for this function? Not symmetric. The function is not symmetric. Very good. Do we need another example? Let's look at one more. Let's say 42 on page 250. And we have h of x equals 2x squared plus x to the 4th. The same question. We're asked to show whether this function is symmetric or not. What do I have to determine? No matter what. H of negative x. Very good. I see the pattern is 2 times the variable squared plus the variable to the 4th. I replace x everywhere by negative x and see what I get. So negative x squared is the same with, good, and negative x to the 4th is the same with, right, so this is 2x squared plus x to the 4th. I have 3 questions to ask myself. Only one can have the answer yes. Does this equal 2x squared plus x to the 4th? Does this equal the opposite of 2x squared plus x to the fourth, or none of the above. I can only choose one answer. And it turns out that the answer is, for the first one is yes, for the other two is no, and the function is even. Which means, why is this so important? Well, for many reasons it's important, but one of them, for example, is when I get to graph it, I don't have to plug in numbers on one of the sides. So if the function is symmetric with respect to the y-axis, once I graph this, then I copy the graph on the other side. I don't need to plug more points in. I just copy the graph because it's symmetric with respect to the y-axis. If it's odd, then I know it will be symmetric with respect to the origin. So what I graph here, I graph here. I don't need more points. So knowing that property or knowing the pattern, it really saves us a lot of time. Okay. I would like us to look at a graph on page 251 if you have the book. If you don't, I will graph it. So here's the graph. Let's look at 52 on page 251. Is this a function? Yes, it is a function by the vertical line test. There's a long list of questions here. Number 1, domain. Very good. With a bracket because it's a full point. Awesome. Range. Stop if you have questions. Range. Do you all agree with negative infinity to 1? The zeros. What did we say the zeros represented? Where the graph of a function crosses the x-axis or the x-intercepts. Same thing. So can anyone give us? Very good. So when x is negative 3 and when x is positive 3. These are the two x-intercepts or zeros of this function. A problem may ask you to write the ordered pair. I prefer the ordered pair. So what do I have to write for the ordered pair? Very good. Next question. F of 0. What am I asked to find now when they say f of 0? They're asked to find what? The y-intercept. So this is the y-intercept. Good. So can anyone give us the y-intercept for this function? Yes, I should have written 1 over there. And this is indeed 0, 1 as the ordered pair. Very good. Intervals on which f is increasing. So I follow the pattern. So f increasing on. Perfect. Negative infinity to negative 2. From the leftmost point till the rightmost point on the x-axis. Very good. Intervals on which f is decreasing. Careful. 2, exactly, till 6. because it's a full point. Very good. So 2 to 6. Intervals on which f is constant. F is constant on very good on -2 to 2. Values of f of x for which f of x is greater than 0. Let's analyze this. This is another very important type of question. Okay, so let's take a look. Okay. I'm looking at this function, and I see that between x values between -∞ and -3, the function values must be negative because the function is below the x-axis. So if you say for x equals -10, I will give you a negative number. So between -∞ and -3, the function is below the x-axis, which means the y values will be negative. Okay, then between -3 and 3, obviously because the graph is above the x-axis, all these function values for x between -3 and 3, they will all be positive. Because if I draw a vertical line here, let's say at x equals 1, I will read a positive value. Now, to the right-hand side of 3, for x values between 3 and infinity, the function is again below the x-axis, which means the function values, the y values, will be negative. So now, knowing this, I can answer my question. The question was, find x such that f of x, which means y, is strictly positive, not equal to 0, but strictly positive. So now let's look at the graph again and say, oh, I know. This function is strictly positive, meaning strictly above the x-axis, between x equals this and this. Do we all see it? So for x values between -3 and 3, the function values are above. So for x between these two, f of x is greater than 0.
Okay, and since we know that at -3 and 3, the y value is 0, how do we connect it? It doesn't include the 2 points.
I don't have the equal symbol here.
Yes, that's what I'm saying.
It says strictly greater than 0.
That's what I'm saying. But it is 0 at -3 and 3.
We're not asked to find where it's 0.
It's a parentheses.
We're asked to find when.
That we've been using parentheses for the entirety.
Very good. This one is an interval. Remember, that's why I like to write x in. Very good point. X in the interval. So now there is no discussion. This is not x comma y. Perfect point. This is one time in which I did not write x in, and it is confusing. So because we are solving this inequality, and we are specifically asked to find x, I should have put it, my error. We are specifically asked to find x. It should be very clear that these are values of x. But I should have written, as I always do, except today, right now here, x in the interval -3 to 3. Otherwise, it would be confused, potentially confused with an ordered pair, x comma y. Very good point. Thank you. Find the values of x for which f of x is -2. So find x for f of x being -2. Like last time, what does f of x equals -2 mean? What do I have to draw when I'm told f of x equals -2? Exactly. I have to draw a horizontal line, and I'm going to my graph, and this is the horizontal line at -2. So this is y equals -2. I see it crosses the graph in 2 points. Therefore, I will be reading 2 different x values. And of course, you cannot read from my graph. I'm going to read them from, so at -2, it will be -5 and +5. So -5 and +5. So I will say x equals 5, x equals -5. And if I want to present the ordered pairs, How do I write the ordered pairs for this?
5,
Very good. 5 comma negative 2, negative 5 comma negative 2, because we have to present x